Pressure is defined as the distribution of force over a unit area of the surface where it is acting on. The unit of pressure is Pascal, which is equivalent to a Newton of force per meter squared. Pascal's law explicitly states that the pressure at one point in an at-rest fluid is the same in all directions. When pressure is applied at the surface of fluid, it will be transmitted equally to all other points in the body. From this phenomenon, we can develop tools such as hydraulic jack and enable us to push heavy stuffs with considerably small forces. Considering a container filled with incompressible fluid. When we are inspecting point A at the depth of h from the fluid surface, we should be aware that the point is overlaid by fluid body with a thickness of h. The self-weight of this overlaying body is an external force acting on that point. From here, we can derive the formulation for pressure at any point within the fluid, and it is dependent of the fluid density and depth. Above the fluid surface, we have air, which contains moving particles. When these particles are hitting the surface of fluid, they exert forces on it. These forces are then induced pressure on the surface. This pressure is better known as atmospheric pressure. At sea level, it is approximately 101 kPa. The atmospheric pressure varies with altitude, where the greater the altitude, the smaller the pressure. By Pascal's law, atmospheric pressure will be transmitted to point A. Therefore, the actual pressure should be the summation of atmospheric pressure and the fluid pressure we calculated. This value is also known as absolute pressure, where we measure the pressure from absolute zero datum. We may neglect the local atmospheric pressure if we are to observe pressure changes at the same altitude. In this case, the datum for our measurement would be the local atmospheric pressure. The difference between the absolute and atmospheric pressures is called gauge pressure. There are two types of tools we use to measure fluid pressure, namely manometer and mechanical gauge. A manometer utilizes Pascal's law and illustrates the pressure difference using columns of fluid. It can be further categorized into simple and differential manometers. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.